This lesson is 3.3, Quadratic Equations and Inequalities. We're going to factor quadratic equations and solve them. We're going to use the quadratic formula and the square root property to solve them, and we'll talk a little bit about discriminants. So let's start by factoring here. Quadratic equation in standard form is ax squared plus bx plus c equals 0. So we will factor this, get two factors that multiply to equal 0, and we'll use the zero product property that says if a times b equals 0, then either a equals 0 or b equals 0 or they both equal 0. So we'll get everything on one side of the equation, factor it, and set each factor equal to 0 and solve. So for this first one, x squared minus 5x plus 6 equals 0. Since everything is already on one side, let's factor it. I know that x squared becomes an x and an x. And then I need to think what numbers multiply to get 6 and add to get negative 5. Since they multiply to get a positive and add to get a negative, I know they both have to be negative. And that'll be a 3 and a 2, because negative 3 times negative 2 is 6, and negative 3 plus negative 2 is 5, is negative 5. So that equals 0. Now each factor equals 0. And we'll solve each one. Add 3 to both sides here, and x is 3. Add 2 to both sides here, and x is 2. And then to finish, write them in order least to greatest, 2, 3 in the squiggly brackets there. So get everything on one side of the equal sign, factor it, set each factor equal to 0, and solve. The second one, I don't have everything on one side, so it's easiest to move everything where the x squared is positive. So the x squared is already positive on the left, so let's move everything to the left. This minus 2x will need to be added to both sides, and the 24 will need to be subtracted from both sides. So that gives you x squared plus 2x minus 24 equals 0. And now we'll factor it. Two sets of parentheses. X squared becomes x and x. And then what numbers multiply to get negative 24 and add to get 2? Since they multiply to get a negative, I know I need a positive and a negative. And they add to get a positive, so I know that the bigger one has to be positive. So since I got one positive, one negative, think subtraction here. In other words, what numbers multiply to get 24 and subtract to get 2? 8 and 3 get a 24, but they don't get a 2. 6 and 4 get a 24, and they do get a 2. 6 times negative 4 is negative 24. 6 plus negative 4 is 2, so that's our factors. X plus 6 equals 0, and x minus 4 equals 0. Solve each one. You get negative 6 and 4. Smallest to largest is negative 6 and 4 in the squiggly brackets, and you're done. So get everything on one side, factor it, each factor equals 0, and solve. Number 3, x squared plus 14x plus 40 equals 0. Everything's already on one side, so let's try factoring it. Remember, they don't always factor, and if they don't factor, we'll have to try another method. So far, these all factor, but you're going to have to check and make sure, because if it doesn't factor, you're going to have to try one of the other methods. So x squared becomes x and x. And are there numbers that multiply to get 40 and add to get 14? To multiply and get a positive, the signs have to be the same, and to add to get a positive, they need to be positive. So I know these are both plus. So let's see, 8 times 5 is 40, but 8 plus 5 is 13. That doesn't work. 10 times 4 is 40, and 10 plus 4 is 14. That's the group we'll use. So make each factor equal 0. Subtract 10, and x is negative 10. Subtract 4, x is negative 4. Least to greatest is negative 10, comma, negative 4. So if they can factor, factor them, because that's the easiest way. Sometimes they can't, and you'll try another method. But if factoring is possible, do it and write the solution from least to greatest. Now sometimes you're going to be able to use the square root property. And that's if you have something squared with not really much else over there. Maybe you have an x squared but no x's. If you have that, you could try the square root property. If x squared equals k, remember we would square root both sides. Square root of x squared equals the square root of k, and then x would be the plus or minus square root of k. It's easy to forget the plus and the minus, but since a positive squared and a negative squared are both a positive number, then we end up getting the positive and the negative. Plus, you can factor it and prove that way as well. Just remember, when you square root something squared, it's a positive and a negative. Now, if k is positive, then we can take the square root of that, and it'll be the plus or minus square root of k. If k happens to be 0, well, the square root of 0 is 0, and plus 0 is 0, and minus 0 is 0, so x is just 0 when k is 0. Now, if k is negative, when k is less than 0, if it's negative, then we're going to have to deal with an I. So remember, when you've got the square root of a negative, you've got the square root of negative 1 as a factor, and really that becomes I times the square root of k. So that's what that one will be. This will be plus or minus I square root of k if k is negative. So depending on whether k is positive, negative, or 0, our answers will be in this form. If you can take the square root of k, then it'll get a little bit more simplified, but sometimes you might still have pieces under the radical. Make sure that it gets as simple as possible. So 2x squared equals negative 20. Since I just have an x squared and no x's here, I could get the x squared by itself and then square root both sides. So let's do that. Let's get the x squared by itself and divide both sides by 2, and x squared equals negative 10. Well, now I'll square root each side. And the square root of x squared is x. This is a plus or minus. Remember the negative here, that's really a negative 1 times a 10. And the square root of negative 1 is I. And then the square root of 10. And 10 doesn't have any perfect square factors, so that's all we can do there. How about this one? I have something squared times 2 equals 12. Well, let's get this solved for whatever's squared. Divide both sides by 2, x minus 3 squared is 6. Then I can square root each side. And you get x minus 3. And over here you get plus or minus. And 6 doesn't have any perfect square factors, so it's still the square root of 6. Now don't stop here. It's easy to say, hey, I'm done, but you're not. You still have a 3 over here with x, and it needs added to both sides. X equals, instead of saying plus or minus square root of 6 plus 3, just put the 3 in front. It is a positive 3, plus or minus the square root of 6. So 3 plus the square root of 6 is a solution, and 3 minus the square root of 6 is a solution. How about 3x squared equals 48? Get it solved for the perfect square, so we'll divide both sides by 3. X squared is 16. Then square root each side. The square root of x squared is x, and the square root of 16 is 4, and that'll be a plus or minus 4. So negative 4 and positive 4 are the solutions there. So if you have something squared and maybe something else you can divide by, and you don't have x squareds and x's, it's just something squared times something else. You can get the perfect square by itself, square root each side, and then simplify it that way. Now sometimes it won't factor, and the square root property is just, it's not going to happen. If that's the case, use the quadratic formula. Ax squared plus bx plus c equals 0. So x equals big old fraction, negative b plus or minus the square root of b squared minus 4ac all over 2a. It looks pretty crazy, but just focus on the 3 parts. The negative b, the b squared minus 4ac, and the 2a. The part under the square root is called the discriminant, b squared minus 4ac. Depending on the value of the discriminant, we're going to have different kinds of solutions, because you can take the square root of a positive, but you can't take the square root of a negative. So let's fill out this table to get the nature of the solutions. If the discriminant is positive, well, you can take the square root of a positive, and remember that plus or minus that you had before the square root, you're going to have 2 solutions, and they will both be real. If the discriminant is 0, well, the square root of 0 is 0, and something plus 0 or minus 0 is the same thing. So you'll end up here with just 1 solution, and that one will also be real. If the discriminant is negative, we'll be taking the square root of a negative, which ends up giving us some imaginary or complex values there. So square root of negative is going to have an I. There's still going to be 2 solutions because you'll have something plus the I and something minus the I, but they will be complex. Just make sure if the discriminant's positive, you're going to end up with 2 real solutions. If it's 0, you're going to only have 1 real solution. And if it's negative, you're going to have 2 complex solutions. So let's use the quadratic formula to solve each of these. Now, if you can factor, factoring is always the easiest way. But if you can't factor, you can still do the quadratic formula. And even if you can factor, you can still do the quadratic formula. So it'll work. It'll take a little bit longer than factoring, but it still works. So we'll do all of these with the quadratic formula. So let's write the quadratic formula here. And have it available. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So here, a is 1, b is 8, and c is 13. So negative b, that's 8, plus or minus the square root of b squared is 8 squared minus 4 times a is 1 times c is 13 all over 2a, and a is 1. Now it looks crazy, but just focus on each part and simplify each part. Negative of 8 is negative 8. That part is now finished. Then the square root. That's a 64 minus 4 times 1 times 13. That's a 52. 64 minus 52 is 12, all over 2. Now each part's simplified. This 12 is the discriminant. It's positive, so I'm going to have 2 real solutions. Now, 12 might be able to simplify, so let's do that. Negative 8 plus or minus 4 is a factor of 12, and 4 is a perfect square. And the square root of 4 is 2. So we get negative 8 plus 2 square root of 3 over 2. Now that is negative 8 divided by 2 plus 2 square root of 3 divided by 2. And negative 8 divided by 2 is negative 4. And 2 square root of 3 divided by 2, the square root of 2's cancel, leaving the square root of 3. And what did I do? Oh, I left off a plus or minus. These should all have the plus or minus in between. So, negative 4 plus the square root of 3 is one solution, and negative 4 minus the square root of 3 is the other solution. 2 real solutions. Number 8. A is 1, B is negative 3, watch the sign there, and C is negative 2. So x equals negative b, so negative of negative 3, be careful, that's an easy place to make a mistake, plus or minus the square root of b squared, and b is negative 3. Remember, a negative squared is a positive, minus 4 times a is 1 times c is negative 2, all over 2a, and a is 1. Now simplify each part. Negative of negative 3 is 3, plus or minus the square root of, I don't need a square root that big. Let's see. Negative 3 squared is 9, and negative 4 times 1 times negative 2 is 8. So 9 plus 8, the negative times the negative is a positive there. So 9 plus 8 is 17, all over 2 times 1 is 2. Now, since I have a positive discriminant, that's a positive 17, I'm going to have 2 real solutions. And some math teachers will allow you to stop here, and we'll just go ahead and say that's fine for now. We have, since nothing else can simplify, 17 doesn't have any perfect square factors. and nothing can reduce. So 3 plus the square root of 17 divided by 2, and 3 minus the square root of 17 divided by 2 are your solutions. If you can factor out, or not factor, but if you can bring something out of the radical, do it. That 12 on question 7, we were able to simplify that. But 17 doesn't have any perfect square factors. How about this last one? Let's get everything on one side first, and it's easiest to put them where x squared is positive, and it's already positive on the left, so let's move these over. I'll have to add the 3 and add the 3x. And you want the x's first before the 3, so we'll do x squared plus 3x plus 3 equals 0. So a is 1, b is 3, and c is 3. So let me make some room and I'll work this over here. X equals negative b, and b is 3, plus or minus the square root of b squared, b is 3, minus 4 times a is 1 times c is 3, all over 2a, and a is 1. Now simplify each section. The negative of 3 is negative 3. 3 squared is 9. 4 times 1 times 3 is 12. So we have 9 minus 12 is negative 3. All over 2 times 1 is 2. Now the discriminant's negative, so I'm going to have two complex solutions here. So negative 3 will need to be rewritten as negative 1 times 3, both under the square root, and the square root of negative 1 is I. That's a 3 there. So that'll be an I times the square root of 3. Now remember, when you have a sum or a difference over a denominator, you can put each one over the denominator. For the complex solutions, you need to do it this way. Since I have an I, put the first part over the 2. That's a negative 3 over 2. And then it'll be plus or minus I square root of 3 over 2. And remember, complex numbers are in the form a plus bi, so the I really needs to come last. So one final step here. Negative 3 halves plus or minus the square root of 3 over 2i. And make sure the I is in the middle of the fraction bar like that, because that way it's obvious it's not on either part of the fraction. It's that much times I. So a is your negative 3 halves plus b, that's square root of 3 over 2i. A plus bi form. Complex roots, complex solutions there have to be written in a plus bi form. So if it can factor, factor it. That's the easiest. If it can't factor, then try the square root property or try the quadratic formula.